Hello and welcome to this video. In this video we are going to move into a new topic, which is complex numbers, and you will see that we're still working with quadratics like we did in Module 2. However, now we are dealing with some new things that can happen with quadratics, and so if you're looking at your examples here, and they've given us this f of x function, and they say put it on Desmos, and you can see I've got a little sketch over here on the side of the function. You can see that this function has two x-intercepts, and it crosses the the x-axis at -2, and it crosses the x-axis at -3. And that means that we have zeros, okay, so x equals -2 is a 0, x equals -3 is a 0, and these x-intercepts are these zeros of the functions. And you've also seen back in Module 2 that these are factors. Okay, so if x equals -2 is a 0, then you're going to have a factor of x plus 2. And if x equals -3 is a 0 of the function, you're going to have a factor of x plus 3. Okay, so that's all review stuff that we've already covered. But now you'll see in this next graph, this g of x here, that when you put that one on Desmos, it looks like this, and you do not have any x-intercepts. Okay, so it's asking us here, how many zeros do you see on the graph? Well, in this particular situation, we don't have any x-intercepts. Okay, so you can say, okay, I'm seeing 0 x-intercepts here, and then but then it's saying how many zeros would you expect this second degree polynomial to have? Well, the degree of a polynomial tells you how many zeros the polynomial will have. So the fact that this is a degree of 2, then we can expect there to be 2 zeros. Okay, but once again, if you think back to the graph, it's like, well, but we don't have any x-intercepts, so where are the zeros coming from? All right, and this leads us into our our complex numbers and how those deal with the x-intercepts and impact the overall zeros of a function. So let's talk a little bit about the complex number system. And the complex number system is going to involve these imaginary numbers, which are designated with an I. Okay, and you've probably seen these before, most students have, and I is the representation of when you're taking the square root of -1. So anytime we have a square root of a negative number, now we can keep going a little further with that algebra and using this I notation. Okay, complex numbers are always written in this form a plus bi, where a is the real part of it and the bi represents the complex part. But a and b are just regular numbers, okay, and then you'll have an I in there. So like some examples could be, like you could have 2 plus 3i. That would be that a plus bi form. Or you might have square root of 3 plus square root of 5i, okay. Or you could have a minus sign in there, some negatives, so maybe you have -7 minus 6i, that kind of thing. So those would all be examples of some complex numbers. So we're looking back here at f of x and g of x, okay, and here's the graphs of each. F of x is in red and g of x is the blue dotted. And we've already talked about how the f of x has the x-intercepts, but the g of x does not, okay. So what's happening here is f of x and g of x both have 2 zeros. Okay, but f of x has what we call real number zeros because those are x-intercepts. G of x, however, has what we call non-real zeros, okay? And those are when you do not have an x-intercept. So you can see down here, Okay, it's talking about G does not cross the x-axis, so it has no x-intercepts or no real number zeros. Okay, so now we're starting to get into the whole idea of a function can have zeros that are real number zeros or not real number zeros. So we have to start distinguishing between these different types of zeros. So if we go to the quadratic formula, okay, and we look at our g of x function, okay, and they have plugged into the quadratic formula. We learned all about that in the last module. Okay, you are getting a negative number up underneath the square root, and that creates, okay, this negative 1 plus or minus square root of 7i over 2. Okay, now down here they're talking about be careful for some common errors. It's okay to write your answer like this. It's okay to write your answer like this, but it's not okay to write that answer this way. Okay, so that would not be all right. That means something different, so watch out for that. And secondly, another common mistake is where students will put the I inside the square root. You can see where that I snuck in there, and you don't want to do that. Okay, so this first way is okay. What I like to do is I like to write my I on the front of the square root like they're showing you on this next example. You can put it on the back of the square root like they did here, but sometimes it's kind of easy to lose track of that I when you write it on the back end like that. So I will typically write it in the front, but either one is technically okay to do. All right, so they're talking you through what this means here. Okay, and you have two zeros of g of x. Okay, you have the 0 with the plus sign, and you have the 0 that had the minus sign. Remember, when you do quadratic formula, you're doing plus and minus, and so you're actually getting two solutions. And these are non-real complex numbers, okay? Non-real complex. So whenever you have zeros of a function that are these non-real complex, they're not going to be x-intercepts. Okay, they're still zeros, but they're not actually x-intercepts. All right, as we saw on the g of x graph. So let's keep just covering some just general information here. Another term you will need to know is what we call complex conjugates. Okay, and complex conjugates are when the sign is opposite. So you can see here we have plus, and here we have the minus. So other than the sign in the middle, they are the same. It's just one has plus, one has minus, and these are considered complex conjugates. Now, complex conjugates are going to be a big part of the rest of our module, and one of the things that you will learn with complex conjugates is when you multiply them together. Okay, you can see they're doing the work here. It actually just multiplies and simplifies down to a regular old real number. Okay, so that's kind of an interesting piece of information that will come in very handy as we progress into some other topics. Okay, and you notice here they're saying we get a real number, and you always have that when you multiply two complex conjugates together. Okay. So our last little information that I want to point out to you here is this terminology here where it says g of x, okay, is an irreducible quadratic function. Okay, so it has non-real complex roots or zeros. Okay, and you will see in WebAssign and in the lab manual and in other videos, you will see these words irreducible quadratic. Okay, and that just means that you're dealing with a type of quadratic function that has these non-real complex roots. Okay, so that's it for this video. In some of the next videos coming along, you're going to learn how to do some of these problems here, do some of this math, and make sure you watch those and learn that. So there's two things going on. You need to understand the concepts of what we're talking about with these zeros being real or non-real, and you also need to understand the math involved with working with your complex numbers. So make sure you watch all the videos and ask questions when you have them.